Guys, so after we have done a little bit problem regarding motional EMF with the same topic motional EMF, usually a question comes from this section, that is rail problems, right? This is a repeated type of questions which is asked in NEET JEE as well as in your board examination. Recently it was even present in around 2016 board exam question paper. It was not recent, but it's an application type question, so better to learn. Okay, so rail means what? You have heard it before, our railway or the path through which the train goes. So this is known as rail, right? So this type of question is usually a figure type question, and this question will be very simple, but the steps are very difficult. It's lengthier process, right? So that's why it is usually asked for 5 mark questions or a part of 5 mark questions. Okay, so suppose let's take with the first question itself, right? So you're given a rail like this is your first rail, so there will be parallel of another rail, right? So horizontal two rails are there, and here there is a rod which is between this one. This is a metal rod, right? Say this rod is having a length L, right? Let's say it has a resistance R and it has a mass M, right? These are the parameters of this rod, right? Connecting to this rod there is an external resistance capital R, right? Here's a capital R resistance. Let's say, okay, this rod is moving with the velocity v in this direction, right? This is the question, right? So you're asked, right, what is the current through the, see, I will, this question is having a lot of subparts. Any questions can be, or any subpart can be asked as an individual question itself, right? So my first question is, what is the current which is flowing through the resistance R, right? Current through the resistance R. So how can I find the value for it? So let's say this is based on something which we have learned earlier, right? So we have learned that, let's take two terminal, guys. Let's say this is B terminal and this is A terminal, right? So I'm going to replace, or I'm going to remove this much section, that is, let's say I'm going to rub off this rail, right? And similarly I'm going to rub off this rail also. Okay, now this is only a single rod, right? Then okay, I didn't write this section, so there is a magnetic field also, right? I mistaught it. Okay, the entire system inside is having a magnetic field B which is into, right? So this much portion which we have already learned, right? This rod is moving with the velocity in the right direction, right? So use your thumb rule, right? So take your palm throughout in the direction of V and turn towards magnetic field B, right? Then the thumb will be towards upward direction, right? So that gives you the direction of V cross B, right? So that means this point A is at which potential? Higher potential, because all the positive charges are accumulated over there, and B will be in lower potential, right? So from where to where, right? So from, that means from where to where the current will be flowing, you can understand now itself. If not, listen. So this is your resistance R. This much scenario I am going to redraw. So higher potential, it can be replaced by the positive terminal of a cell, right? So that this cell will be having an EMF, remember, it is E is equal to VBL. This and all I have taken earlier, right? So this is a cell or replacement of that rod. If this is a cell, to draw the circuit again, guys, here. So this is capital R, right? And there was a cell which is the replacement of the rod, but along with it I forgot a small section. There is a small resistance R, right? The rod is having a resistance R, had been told in the question itself. So this rod is to be replaced by the cell and the resistance small r, and the EMF of the cell is E is equal to VBL. And how is the direction of current? Just like this, right? So in this rod also the current will be in this direction, right? And what will the equation of current? I is equal to, according to this circuit, is EM of E divided by R plus small r. That is the question's answer. You were asked what is the current, right? So this is the equation of current. But see guys, what is E? In the equation or the figure itself, I have written it as VBL. So in place of E, I will write VBL by R plus R. That will be one of the option as per the examination point of view. Clear? Easy. Now the second type of question for the same question, that is same question, that is two railroads. Sorry guys, the railroad was horizontal, right? So the horizontal railroad, right? And the question is, after we have found the current, you are asked what will be the external force, right? There is a minimum external force that has to be applied, right? So that it is in the balance, right? The minimum force which is required so that the rod can move with that constant velocity. Okay, I will explain it again. Suppose the same scenario guys, we are having horizontal rod or rails, sorry, and you are having a rod like this, right, and the rod is connected to an external circuit resistance like this, right? This was the question, right? And this point had higher potential, this point had lower potential, same scenario, and the magnetic field works like this, right? And this is the direction of L vector then, right? So if you have L and you have B, right? So see, I just told you this rod can be replaced by a cell, right? And the rod is having current in this direction, right? So tell me any conductor which is having current passing through it, current carrying conductor, when kept in an external magnetic field, it experiences a magnetic force, remember, and it was given by the expression I L cross B, taught in your earlier class, right? That is a force experienced. So can you give me the direction of this force, in which direction this force or this rod is going to move? Already this rod is moving in this velocity direction, right? So but due to the presence of magnetic field, this rod is having an induced current, that expression we found earlier. Now induced current has caused this rod to experience a force, right? In which direction it will be, right? Again, it is a cross product, right? This force depends upon the direction of L cross B. L cross B means take your fingers in such a way that it is all pointing in L direction. Turn your fingers in B direction means all the fingers has to be downward. The thumb gives you the direction of force, right? So remember, so in which direction the force is? You guys can find it very easily. In which direction, guys? Okay, I draw the figure wrongly, right? Sorry. This is your right hand, right? I drew a left hand. So right hand means your fingers, all the fingers will be the direction of L like this. And when you turn your fingers B downwards, thumb will be in this direction, right? Right. So that means the force is in this direction, Fm, right? I'm going to redraw the entire thing just with a rod, right? So this is my rod, higher potential. So this means this is your L vector. This is your magnetic field B, and you just found the direction of force in this direction, right? Simple. Now the rod is already moving with the velocity v, we told earlier, right? So now there is a force Fm which is acting backwards. So to keep the velocity constant, right, to keep this velocity constant, we have to apply an external force which is in the opposite direction as that of Fm, right? We have to apply an external force which is opposite direction of that Fm, and minimum condition, right, or the minimum force should be, which should be applied, should be equal to this value, right? That is F external should be equal to Fm, right? And we just found the value of Fm. We know it is IBL. Why did I take it as IBL? Cross product, right? Cross product means sine theta, and here it is what is the angle between L and B? It is 90 degrees, so it is just IBL, right? Now we are going to write the expression again, guys. So F external, right, is equal to, right? In place of I am going to write it as VBL by R plus R. We just found the expression for current earlier, right? Into, there is a BL term now because IBL, this is I and then BL, right? So the expression becomes V B squared L squared divided by R plus R. This is the equation for minimum external force that is required or that is to be applied so that the rod can move with a constant velocity v. समझ में आया? Right. So this is a very important scenario, guys, and it is very easy to understand. Also, it's not that much complicated until and unless you make it complicated. Right. Now we'll do the third part of the same question. You are asked, find out velocity of the rod as a function of time, that is v of t. Velocity of the rod with the, that is we just told it was going to move with the velocity, right? What will be the value or what will be the expression of that velocity with respect to time? That is, the expression should be in terms of t, right? Again, repeating the scenario, we had this long resistance, right? And we replace the rod with a cell, remember, and a small resistance, small r, that is the rod's internal resistance, or can say just the resistance, and the EMF of the cell was VBL, and we found the expression of I as what? VBL divided by R plus R, right? And we found the magnetic field equation also, right? That was IBL, which is the force experienced by the rod, right? Now Fm can also have an equation. What was the direction of Fm? It was in this direction. What was the external applied force? This would, right, this would be the Fm, this was the F external, remember? And this Fm, right, is equal to mass of the rod into the deceleration. The deceleration, because it is in the opposite direction, the rod is actually moving in this direction, right? So this direction will be decelerated form. So I can write here minus, right? So Fm is IBL as well as Fm is equal to minus MAC. So I can replace here as this, both equations can be equated as IBL is equal to minus MAC, right? That means I'm going to rub it off this much portion, guys. Sorry. Okay, so and here I'm going to write what is AC. You are asked velocity, right? So you can find acceleration, then you can go for velocity. So it will be what? Minus IBL divided by M, right? Now we just found the value of I. Replace that value with I, that is VB squared L squared, because there are two terms, right? Divided by M into R plus R, right? That is your acceleration equation. Sometimes this is directly asked, right? So you found acceleration. So what is acceleration? It's dV by dt. So I will write it as minus V B squared L squared divided by M R plus R, right? Now what we are going to do is bring some common terms. So here there is a V, I am going to bring it down. So that becomes dV by V is equal to minus B squared L squared divided by M R plus R, and dt goes up here. Simple. Now I am going to integrate, because I want to remove the dV term. So I have to integrate both these terms, right? dV from 0 to V, and this is from 0 to T. The initial time is, or initial velocity is 0, initial time is 0, maximum velocity is V, maximum time is T, right? Now you guys have to know integral 1 by x is log x, or I can say natural logarithm x. This should be known, guys. That is integral formula. Math students would know this equation as it is, right? Now I'm going to replace this or find the value for the integration. So here it is 1 by v dv integral. So it is what? ln v upper limit, lower limit. That is the integral of this part, right? And this b squared l squared, right, divided by m into r plus r is a constant term. So this much portion when it comes off, there is also only just integral 1 dt. Integral 1 dt is t. So it is minus b squared l squared divided by m r plus r, and there is just a t. Right? Now the next step is, I'm going to rub this section off, guys. Next is, see, integral, let's say initially I just told, right, initial velocity is 0 and the final velocity is v, right? Sometimes it might not be there, right? Suppose there is an initial velocity v naught. Initial velocity is not 0, let's say like that. So this integration will become integral v naught to v, right? And it would have been dv by v, right? So I will write it as ln natural logarithm v and the upper limit v, lower limit v naught, right? Let's say like this. Suppose you are given an initial velocity. So the LHS side, I'm going to write it this form: ln v naught is equal to minus b squared l squared divided by m r plus r, and then there is a t. Right, so this term I can write natural logarithm v, subfix this one with v and v naught, minus natural logarithm v naught, upper limit minus lower limit, is equal to minus b squared l squared t divided by m r plus r. Right? Now this formula you have to know, that is log a minus log b is log a by b, or log a by b is equal to log a minus b, right? So this term I can write it as ln, LHS side, okay, ln v by v naught, right, a by b is equal to minus the same term, right, this much term, right, minus b squared l squared t divided by m r plus r. Okay, this much surely you understood, I believe. So this much part I am going to rub it off. This can be now written as, now I want the value of v only, right? That's what I have to remove the log. That means I have to introduce the term called anti-log. That is opposite of log, or I can say inverse of log. So when anti-log comes off, then anti-log of log is nothing, it goes off. So it becomes v by v naught is equal to, then this term, this is the expression, guys, this entire term becomes the exponential of e, that is minus e raised to minus b squared l squared t divided by m r plus r. Right, then just v will be equal to v naught into, right, this much part I am rubbing it off, v naught into, let's say I am going to rub here fully, let's rewrite it, v is equal to v naught, this is going up, e raised to minus b squared l squared t m into r plus r. This is the equation for velocity of the rod as a function of time. Right, it's not tough, take your time. This is just an integration and differentiation etc. is used. Take your time, this is just a formula, guys. That is, if there is a log, when antilog is brought, that entire log for logarithm function goes up. But if I am bringing antilog here, then antilog has to be brought in this section also, right? So antilog, when it is brought here, then it becomes an e raised to function. Just remember like that, because it's a very big thing in the case of maths. And I would request the biology students to ask your maths teacher to take your exponential or anti-log and log section. I think this much section has been completed in your 11th itself. Okay, now let's move on to a similar question, guys. We are going to replace this question with a little bit change. That is, earlier we learned about what? Horizontal rod Now we are going to replace the rod with a vertical rails. So you are having a vertical rail like this, and you are having a rod like this. Okay, right, and the rod is like this, and the rod is again connected to a external supply or external resistance, say, and all the parameters are same as it is, right. And then there is a magnetic field B, and the rod is of length L, mass M, and resistance R. Again the same question, find the velocity v of t as a function of t, right. And let's say the velocity by which it is coming down. Okay, it is coming down with the velocity v, say, right. So first of all, we find to replace this rod with the cell. So again resistance R, and this becomes a cell. So which should be the higher potential, lower potential? Take your fingers in the direction of V, turn your fingers downwards. The thumb will give you the direction of V cross V, and this you will find this point is higher potential, and this point is lower potential, right. So this is higher potential, lower potential means the L vector will be in this direction. I'm going to take this first because I have repeatedly taken in this, guys. So high potential means the cells, this is positive terminal, this is negative terminal. The current will be flowing in this direction, that is inside the rod the current is in this direction. If you are okay, I will take another color. This is the direction of current inside the rod, right. So right, this is, oh sorry, the current's direction is opposite now. So the current's direction is in this direction. Okay, clear, in this direction, right. So and the current's expression, just like the previous case, I is equal to what? VBL whole divided by R plus R, just like the previous one, right. Now remove the entire scenario. We're going to redraw it. That is, this has been the rod, right, and the current was flowing in which direction, guys? The current was flowing in this direction, right, and the L was in this direction, and this was the magnetic field. So find the L cross B so that you can find the force, just like the previous case, because force is equal to I into L cross B, right. So L cross B gives you the direction. Take your fingers downwards, and the force is in which direction? Force is in this direction. Thumb will be giving this direction, right. That means actually the rod was falling down with the force of gravity, right, whereas the force due to magnetic field is acting in upward direction, right. So you know the rod is falling down, right. That means force due to gravity is greater than force due to the magnetic field. That's why it is falling down, right. So that means the net magnetic field will be the difference of this force, right. The rod experiences a net force, right. The net force will be equal to, which is greater, Fg minus Fm, that is a force experienced by the rod, right. Now in place of Fg, that can write it as the force due to gravity is mg is equal to, or I can say is minus, right, Fm becomes IBL, just like the previous case, right. That is equal to the net force which is applied or acting on the rod can be MAC, that is mass into acceleration of that rod, right, just like the previous cases. AC can be written as G, right. This M goes down to all the sections, so it becomes IBL by M, right. Now let's replace this I value, that is G minus I can be written as B squared L squared divided by M R plus small r. This is your AC, right. Now AC can be written as what? dV by dt, just like the previous case, right. Now I'm going to write dV by dt, right, is equal to G minus VB squared L squared divided by M R plus R, right. So let's bring this term here, so multiply with G, so it becomes GM, or I can say MG, that looks good, MG R plus R minus VB squared L squared whole divided by M R plus small r. Just rearrangement, that is equal to dV by dt, right? Just like the previous case, bring the terms which are close to v in one side. So that means this numerator has v content, right? So I'm going to bring that downward and dt upwards. That is just like cross multiplication. So listen. So I'm going to write it as integral, right? Suppose initially the rod was at rest. So the initial velocity will be 0, right? Right, say that now the new velocity is v. Suppose they had given an initial velocity, then that should be written over here, right? Suppose in this question I'm telling you initial velocity was 0, right? So dv, right, and the v term comes downward here, right? So capital R plus small r minus v b squared L squared, that was in the numerator here, is equal to integral. This is from time term, right, dt. So it is 0 to t, and the new denominator is having m r plus small r, right? This my section is very easy, just rearrangement. Now this comes the integration part, guys. There is a formula which you have to learn. Integral dx whole divided by ax plus b is equal to 1 by a natural logarithm ax plus b. Just by heart this equation. This is an integration formula. Integral dx divided by ax plus b is equal to 1 by a natural logarithm ax plus b, right? So here in this term, compare this term with this one, right? So this b term is a constant term which doesn't have any function, guys. So b, right, that means this part. A is with x, here x is v, right? So here x is v means this is v, right? So x goes off, then the a term is this b squared L squared. Compare it, right? So which term is a? A is, as per the equation, is b squared L squared, right? And v is like x. So you have to replace with this equation, right? So what does it become? Remember, so that means there is a minus term. Why? You are writing this as minus vb squared L, right? v b squared L squared, right? So there is a minus term in that function. Initially it was integral dx divided by ax plus b, or I can write it as what? Integral dx by b plus ax, right? So compare this term with the earlier one which you have as a problem. What? Integral, right? Integral dv divided by mg r plus r minus v b squared L squared, right? So this b, this entire term, this a term which is with b, right? So here in place of plus there is minus. So the answer should be also is 1 by a, right? So here there will be a minus. So let's say, so minus, what is 1 by a? What is the a term here? It is b squared L squared, right? So minus 1 by b squared L squared. And what was the rest of them? Natural logarithm bracket ax. What again? Ax is what? B squared L squared, but minus content ax, right? So it is what? V x content plus b. What was b? mg r plus r. Just you replaced it, right? And there should be an upper limit and lower limit. Very easy, don't confuse it, guys. Take your time, compare how I've got the answer. Just compare the equation which you have got and replace the values. That's it. Clear? And in RHS it is same as it is. That is the constant term, right? So constant term is mr plus r, and that is integral dt. So it becomes just t comes out, right? And then upper limit, lower limit, this is t 0. Right, now we are going to just apply the values here. And you can either stop till here itself. If it is a 5-mark question, no one is going to stop, means tell it is wrong. But it's easy, I will do the steps entirely. Minus 1 by b squared L squared, natural logarithm right? Again, upper limit minus lower limit, right? So the entire term, this is only term which is having b, right? So I can write natural logarithm b minus b squared l squared v plus mg r plus r. That is the first term, minus, there is a bracket for the entire thing, right? This is common for the entire thing, minus natural logarithm. Upper limit is completed. When I put the lower limit, this is 0. So when v is put 0, this term fully goes 0. So this much part only remains. So this is mg r plus r. That's it. And this bracket is closed. I'm just continuing with the LHS part, guys. RHS, let's keep it as it is, because when t is put 0, the second term, upper limit minus lower limit term will totally becomes 0, right? So let's move on with the LHS part only. So what is natural log a minus log b? It is log a by b, right? Similarly, when natural logarithm a minus, this is a, right, minus natural logarithm b, it is natural logarithm a by b. So this I'm going to write it as, right, minus 1 by b squared l squared natural logarithm mg r plus r minus vb squared l squared divided by mg r plus r. I just changed the order, guys, it's same, right, is equal to t divided by m r plus r, right? Clear? Now I'm going to bring this b squared l squared in here to here. So this becomes natural logarithm mg r plus r minus vb squared l squared divided by mg r plus r is equal to b squared l squared t divided by m r plus r. Simple, right? Now you just have to find the b, right? So here it is natural logarithm. So in order to remove the log, I have to introduce anti-log here. So the anti-log also introduced here. So this entire function becomes e raised to, right? So here it is mg r plus r minus vb squared, because the log term goes off, right? And there is a denominator mg r plus r is equal to e raised to minus b squared l squared t divided by m r plus r, right? Now this term can be brought here, and then you can just subtract the value of v, right? This term goes over here, and then it could so I'm just writing the answer. Listen, mg r plus r, right, minus vb squared l squared is equal to mg r plus r into e term. I'm not writing the entire thing, e raised to this function, right? Then this term to be brought, mg r plus r, right, this goes over here, this goes over here, minus mg r plus r e raised to this function is equal to vb squared l squared, right? Then b squared, or I can say v is equal to 1 by b squared l squared, that goes off here, right? mg r plus r, I can bring that as common, 1 minus e raised to that function b squared l squared. I'm not writing the entire thing. You'll get the answer like this. This is a velocity function with respect to time. Okay.